Hello, everybody. So we're going to do a calculus review today. Also, I'm writing in my old high school calculus notebook. Um, so that's fun. Calculus review guide. Okay. So part one, we're going to talk about derivatives. Part one, derivatives. Okay. So first, remember a derivative is a rate of change. And it's also the slope of a tangent line. Okay, so if you have a function that maybe looks like this, you will have, let me find two different colors. Sorry, got one. Okay. So you will have little, at certain points, maybe there on your curve, you'll have little tangent lines that come off. Okay, you can calculate the slope at that particular point, but then there are also points on your curve, like here or there or there, where you will have a slope that is defined as 0. These are your mins and maxes. That's one of the super important points in the whole finding derivatives thing. Okay, so graphs. Let's talk about graphs and how these derivatives apply. Okay, so remember, if f prime of x is less than 0, then our f of x is decreasing. Okay, so the derivative less than 0, so it's negative. The actual function is decreasing, going down. Okay, similarly, if f prime of x is bigger than 0, then f of x is increasing. So going up in some way. Okay, and finally, if f of x is equal to 0, then f of x has a stationary point. Okay, this means it's one of these little purple guys up here. Okay, it has slope 0. All right, so stationary points. Oops. Okay, so stationary points we find by taking f prime of x, setting it equal to 0, and solving for x. Okay, we classify them. Well, classifying means to decide what type they are. Okay, and there are 3 different types that we can have. We could have a max, a min, or a stationary point of inflection, and those have to look one of these 2 ways. They're the same except one, well, this one I did a bad job of. One is like decreasing and one is increasing. And remember, this is a stationary point of inflection. POI stands for point of inflection. Okay, this one is going down and then down. This one's going up and then up on either side. Remember, over here with a max, you should have a plus. At the stationary point, you should have a 0 and then minus. These are the signs of the derivatives, by the way, sorry. And then, yeah, no, I did that right. And then negative 0 plus. So this one's going up and then down. This one's going down and then up. okay? And then it's 0 in between. So 0 right here, 0 right there. So this one's like -0, negative. This one's +0, plus. Okay, so that's the difference between all that stuff. And you classify them by creating this chart with x and then f prime of x. You'll have an x value less than your stationary point, then your stationary point, then an x greater than your stationary point. Okay, and your stationary point, f prime of x value should always be 0. Okay, so you're just checking on either side of it. Okay, so all of this stuff right here is your first derivative stuff. Oops. Derivative. Okay. Whoops. So that's all that stuff. First derivative. Okay. Now there's also stuff we can do with our second derivative. Oh boy. All right. So with our second derivative, there's some things we can find if, f double prime of x is less than 0. This means that f of x, the original function, is concave down. Okay. If f double prime of x is greater than 0, then f of x is concave up. Okay, so it's going to be like this guy. And if f double prime of x is equal to 0, then f of x has a point of inflection. Okay, and this is only true when concavity also changes. Okay, so let's review points of inflection a little bit. So points of inflection. Okay, so this is when concavity changes. So maybe we have a curve that goes like this. The point of inflection is going to be right here. And then to the left, we would have concave down. To the right, my pen flew across the room. Hold on. We would have concave up. Okay. Similarly, you could have like the opposite thing happen. So you could have like concave up first and then concave down. And the point of inflection is right here where the concavity changes. So first we had concave up. Ooh, that's ugly. Oh well. Then we had concave down. You also could have the stationary point of inflection thing where it kind of looks flat in the middle, but you still have a concave up section here and then a concave down section here. Okay. And it can be the opposite way as well. So to find these, we solve f double prime of x equals 0. Okay, and we have to check, does concavity change? Okay. All right. And let's see here. So in order to do this, we would take x and we would make a table, but this time we have our table with f prime, double prime of x. We pick an x value less than our point of inflection. We pick our, I guess we could do that, equal point of inflection. And then we check when x is greater than our point of inflection. It's always going to be 0 at our specific, point of inflection. And we have to look for a sign change. Okay, so all of this stuff right here is for our second, that was ugly. Oh, well.